Hi, I'm Swarupa Sail, course instructor for fluid mechanics. In this presentation, we will solve a problem based on Bernoullis equation. A 400-meter long pipe tapers from 1.2 meter diameter at section 1 at high end to 0.6 meter diameter at the low end. The slope of this pipe is 1 in 100. So this pipe is not laid at horizontal direction, but it is inclined with the slope of 1 in 100. The pipe conveys a discharge of 1.25 cubic meter per second. If the pressure at the high end, that is P1, is 75 kPa, we need to find out what is the pressure at the low end. And here it is mentioned that we need to ignore losses. So to begin with, we will write down the given data. D1 is equal to 1.2 meter, D2 is 0.6 meter, Q is 1.25 cubic meter per second, P1 is 75 kPa. With these data given, we need to find out what is P2. So to find P2, we will use Bernoullis equation, that is head at section 1 H1 is equal to head at section 2, that is H2. H1 is summation of datum head, that is Z1, pressure head, that is P1 by W, and velocity head, that is V1 square by 2g. Since H1 has to be equal to H2, H2 can be written as Z2 plus P2 by W plus V2 square by 2g. In this equation, all the datas are known except P2. So we need to find out P2. Here in this problem, the value of Z1 and Z2 are not given, but instead we are given the total length of the pipe and slope of the pipe. So length of the pipe is 400 and slope is 1 in 100. So we can write Z1 minus Z2 as equal to 400 divided by 100, which is equal to 4 meter. P1 by W is equal to, P1 is 75 kPa, that is kilonewton per square meter, and W is 9.81 kilonewton per cubic meter. So here we can observe that the units of both the terms, that is P1 and W, are in terms of kilonewton. If 75 is written in terms of Newton, then it becomes 75 into 10 raised to 3 divided by W also has to be written in Newton per cubic meter. In that case, W will be 9810. But here both the terms are not written in terms of Newton, but they are in terms of kilonewton. So 75 kilonewton per meter square divided by 9.81 kilonewton per cubic meter will give us the value as 7.645 meter. Now we will find out what is V1. V1 is equal to Q divided by A1. Q is given as 1.25, area is pi by 4 D1 square, D1 is 1.2. So when we substitute all the values, we get V1 as 1.105 meter per second. Similarly, we can find out V2. Considering discharge is same at section 2. So V2 is equal to Q divided by A2. Q is 1.25. A2 is pi by 4 D2 square. D2 is 0.6. So we get V2 as 4.421 meter per second. Now we will substitute all the values which we have found out to get the value of P2. P2 by W can be written as equal to Z1 minus Z2 plus P1 by W plus V1 square by 2g minus V2 square by 2g. Z1 and Z2 is equal to 4. P1 by W is 7.645 plus V1 square by 2G. G here is 9.81. So we get V1 square by 2G as 0.062 minus V2 square by 2G is 0.996. So after we calculate, we get the value of P2 by W as 10.711 meter. This is what is the pressure head, and if you want to find out pressure P2, we need to multiply W to 10.711. So 10.711 into W, that is 9.81, will give us the value of pressure at section 2 as 105.07 kPa. Thank you.